All right, today we start our last unit. This one is also on circles. We'll do some other angles other than central angles, and then we'll do a little bit about the equations of a circle. And that'll finish up our year for us. So today we're going to look at a different kind of angles. The only angle we looked at in the last unit was a central angle. A central angle was an angle who had its vertex at the center of the circle, and its measure was equal to the measure of the arc. Today we're going to talk about something called an inscribed angle. The word inscribed is, the root word is scribe. Scribe just means to make a mark or to write something. So when it says it's inscribed, it's marked or written inside the circle. Specifically, its vertex is on the circle, like here. KHD is an inscribed angle. Its sides are both chords. The sides both have to be chords to be an inscribed angle. So KHD down here is an inscribed angle. An intercepted arc, in football for example, what does it mean when you have intercepted it? Yes. Pardon? Right. And you do that by cutting it off from its intended destination, right? Intercept actually means more generally to cut something off, right? So if we follow this arc out here, or excuse me, the angle, it hits the circle at K, it hits the circle of D. And although it's a little bit silly, if you follow our football player, those are his hands. The ball's got to be in between them for him to catch them, right? Unless you have enormous hands and you can palm a ball or something like that. But most of us mere mortals can't do that. So the intercepted arc is the arc that's in between the two hands of your defender here. Okay, and again, I know it's a little silly, but you get the idea. So an intercepted arc is made of the endpoints that lie on the sides of the inscribed angle and all the points in the circle in between them. So it's everything from K to D on the circle. We say a chord or an arc subtends an angle, and you won't see this one a whole lot, but it's a term that you should know, if its endpoints lie on the sides of the angle. So here, KHD is an inscribed angle. We say that arc KD is an intercepted arc, or we can say that arc KD subtends angle KHD. Subtends, it connects the ends, like a subway connects things together. It connects those two ends together. You can also have, you don't need to draw this, but you can also have chord KD subtends angle KHD because it connects the ends. Okay? All right, so everything we do today is going to come from this one theorem. The measure of an inscribed angle is half the measure of its intercepted arc. Unlike a central angle where the angle is equal to the arc, an inscribed angle is half the arc. Okay? I'm going to real quickly show you why. You don't have to remember this, but I think by now you guys know that I'm real big on understanding, well, why does that work? So what we're going to do is we're going to start with the circle. And to make it easier to explain, I'm going to draw a diameter. Again, you don't need to draw this. I'm going to draw in a central angle. And then I'm going to draw in an inscribed angle. So yeah, I know this is the same line, but so let's say that this angle is, I don't know, how big do you think this arc is? 70? Okay. So then this would be 70, right? The central angle is equal to the arc. Easy peasy. How much is this angle right here beside it going to be then? 110. Because those are a linear pair. Yeah, they do add up to 180. They are a linear pair. And again, I can make good on my promise from way back in August when I told you this will keep coming up for the rest of the year. All right. You're like, okay, well, that's nice. Now this triangle. I know that this triangle is isosceles because all radii in a circle are the same length, which means that these two angles have to be the same size. Right? If I subtract 180 minus 110, I get 70. So cut that in half. Each of these has to be 35, and this angle is half of the arc. I'm sorry? I don't remember how what?
Is it not also equal to the same?
This angle right here is smaller than this angle right here. In fact, it's exactly half the size. Okay. Pardon? Yeah, but you don't have to draw all this out and do it all. You just know that the inscribed angle is half of its arc. It's a lot simpler than that. I was just showing you why it worked. And I let you guys pick the angle. You could have picked anything and it would have worked. Yes?
So, that little triangle got intercepted by that line right there. And the angle.
The arc is intercepted by this angle. Okay? All right, so let's do some example problems. So for this first one, we want to find the measure of arc ADE, this great big major arc over here. You're like, okay, well notice across from it is this inscribed angle, angle ABE. Again, think of that as it's got its arms out. What it catches is going to be, the angle is going to be half of the arc. So if 125 is half of the arc, what do we have to do to find the whole arc then? Yeah, multiply by 2. And you don't have to write all that out when you're doing problems, but this is what's going on. The measure of arc ADE is 250 degrees. I'm going to switch colors here. Let's use orange. I don't use that very much. So if I'm looking for angle DAE, again, if you start from the vertex and follow that, that doesn't really show up on the red very much, does it? Let's do black. That'll show up much better. That is an inscribed angle because its sides are both chords. The arc that it intercepts is 78. So the measure of the angle is half the measure of the arc. So it'll be half of 78 degrees, which is 39 degrees. So again, with an inscribed angle, the measure of the angle is half the measure of its arc.
How do we know what the inscribed angle is?
So you're saying, like, if I have an arc, how do I know which angle is its inscribed angle? Sometimes there's more than one. I'll show you that in just a second. But if you have an angle where that whole arc fits right between the two sides of the angle, that's the angles that goes with that arc.
Do you have an angle that fits between two?
I'm sorry?
Do you have an angle that fits between two?
If you have an arc that fits between the two sides of the angle, then that angle belongs with that arc.
That's the inscribed angle too.
Yeah, the vertex has to be on the circle. We'll talk later on about what happens if you have one that looks like this. where the vertex is not on the circle, how you can find this angle from this arc and that arc, but not today. All right, let's look at this next example. We're trying to find the measure of angle EDF. Again, if I follow angle EDF out from the vertex, what arc does it intercept? Arc EF. But they didn't tell us the measure of EF, so that doesn't feel particularly helpful. But notice they also gave us angle G's measure, and if I follow angle G, what arc does it intercept? It also intercepts EF. It's the same arc. So each of these angles is half of EF. And again, you probably would never write this, but I'm going to show it to you. I've got, so that means that 2x plus 3 is half of arc EF. And 7x minus 25 is also half of arc EF. So what does that mean about our two expressions here? They're equal to each other. So 2x plus 3 is equal to 7x minus 25. It'll be 5x equals 28. So divide by 5 and you get x is 28 fifths. I would not make it a mixed number. Anytime you're going to have to substitute it back in, it's not nice. It does turn out to be a fairly nice decimal, so I'll do that. It's 5.6. So the measure of EDF is going to be 2 times 5.6 plus 3. This is 11.2 plus 3, so it's 14.2 degrees. Okay, let's go on to the back. This next theorem is just an extension of the exact same idea. An inscribed angle is subtended by a semicircle if and only if the angle is a right angle. So if you look at this diagram, if I follow angle Y, which is an inscribed angle, it hits the circle at K and at R. What's the measure from K through A to R? 180, because this is a diameter. So what kind of an angle does this have to be? It has to be 90. So that angle is going to be a right angle. And it works the other way as well, although you don't see that as often. If they give you that this is 90, well, then you know that this arc over here has to be 180. I promise you, at least once during this unit, I'm going to give you a diagram where there's no numbers given at all. I'm going to ask you for an angle, and it's going to be this problem or one like it. And there will be someone who will go, yeah, you didn't give us any numbers on this one. And the rest of you can kind of laugh at them gently. Okay? You don't need it because you know that this is 180 degrees over here because it's a semicircle. All right, there's not much else to that theorem. Last theorem today is this one. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So in this picture, angle J and angle M are supplementary. What does supplementary mean? They add up to 180. Thank you for saying they add up to 180 and not saying that it is 180. And then A and E are also going to be supplementary. It's the ones across from each other that'll be supplementary. Why is that? Again, you don't need to draw this, but watch for just a moment. If I follow angle J, it hits the circle there at A and at E, right? So its intercepted arc is from A all the way around to E, right? If I follow angle M, let's use brown. I don't think that's going to show up on the red. The yellow won't either. We'll use black again. Oh, that is black to start with. Let's use red. If I follow angle M out, M hits the circle there at E and at A. The arc that it intercepts is this arc. What do you know about that red arc and that blue arc? They add up to 360. And each angle is half of its arc when it's an inscribed angle. So together, they're going to add up to half of 360, which is 180. That makes them supplementary. Okay. There'll be problems like this on your assignment tonight. Guarantee there'll be a problem like this on your quiz, and there'll be a problem like this on your next test. Guaranteed. One exactly like this. Just different expressions. So let's do this problem. We want to find the angle measures of TLMD. And they give you 3 out of the 4 in terms of B. There's only one equation you can write to start this. We know that the opposite angles are going to be supplementary. I can't start with T and M because I have no information about angle M. But I can start with angle D and angle L. So I'm going to say that 3B plus 25 plus 6B plus 20 is equal to 180. Those opposite angles are going to be supplementary. Group the like terms, and we've got 9B plus 45 is 180. Subtract, and we have 9B is 135. Divide, and we have that B is equal to 15. So now we can find the measure of angle D. Will be 3 times 15 plus 25. Let's see, that's 45 plus 25 is 70. The measure of angle L will be 6 times 15 plus 20. Let's see, 6 times 15 is 70, 100? Is that, it's 90? Plus 10, or plus 20 is 110. And that should check out that those two are supplementary. And it does. But now we can keep going. We know angle T. Its measure is going to be 10 times 15 minus 69. That's 150 minus 69. Is that 81? But we still haven't found the measure of angle M. We can't find it by substituting, but we know the opposite angles are supplementary. So we just do 180 minus 81, and that's 99 degrees. Any questions? Okay, then your assignment is in the book.